So resolution is our next topic of discussion. It means rules of inference. By inference, we mean that deriving conclusions from evidences. So we'll be having some statements as facts, which is called as knowledge base, and these are the evidences. And we'll be concluding a result from these evidences. That is called as resolution. A method used for such conclusion is known as resolution. So as I have said, evidences will be given as facts or statements. Hence, the rules of inference can be the templates used to construct valid arguments. From these arguments, we can create more complicated valid arguments. We have seen these things in self-learning approaches in knowledge bases. So we can create new evidences from the existing evidence. That is the summary of the topic. It's usually used in mathematical logic. Actually, this is a topic from discrete mathematics. I don't know whether you have gone through this topic or not. And it is widely used in theorem proving. It uses a method of refutation, which means we start with a contradicting statement and finally conclude that our assumption was wrong and thus get into the proof of the theorem. So resolution rules is applied iteratively. It is a repeating process, and there are different types of inference rules available. I have put a video on this, and you can have these different types of inference rules from there. The resolution principle is used to prove whether an argument is true or false. We can prove whether an argument is true or false by using resolution principle. And let us see some terminologies associated with this. First one is a literal. A variable or negation of a variable is called as a literal. Suppose if we say A, then A is a literal, not A is also a literal. Then we have a clause. Disjunction of literals like A or B is called as a clause. Then we have a resolvent. A clause produced by a resolution method is called as a resolvent. It is obtained by deleting complementing literals and forming new clause with remaining literals. We will be comfortable with this topic when we see some examples. Suppose we are having a literal as A or B, then another as not A or C, then we can delete this A and not A. They are the complementing literals, and finally reach to B or C. That is called as a resolvent. So it is obtained by removing the complementing literals, and will be taking into consideration of the remaining literals to form a new clause. This is also explained with a video, and that has been attached to this running topic. And then we have some steps for a resolution. First one is, as the definition says, we have to negate the statement to be proved as assumption. Suppose we want to prove A is even, we have to assume that A is not even and proceed with the steps. And finally, we will get into a wrong spot, and we will declare that our assumption went wrong, and then the only possibility is that A is even. Likewise, this resolution method will be proceeding. So the first step is to negate the statement to be proved. It is just an assumption that the statement is not true. Then we will be given with some facts which are called as the statements or the knowledge base, and they should be converted into first order logic. Then this first order logic should be converted into conjunctive normal form. We have to remove some quantifiers if there exist when on conversion into FOLs, or some implications that has to be removed. Such form is known as CNF, or conjunctive normal form. Then we have to draw a resolution graph. Finally, we will end up with the resolution or goal of our problem. Then before moving on to this resolution, let us see what is a conjunctive normal form, or in short we can say that it is CNF. In propositional logic, the resolution method is applied only to those clauses which are disjunction of literals. So when the literals are disjunct, then only we can apply this method. So the steps involved for CNF are: we have to eliminate biconditional implication. Then we have to eliminate implication, if any. Then move the negation inward. Then use the distributive law on the sentence. Let us see them one by one. So eliminating biconditional implication. And suppose that A double implies B. Then we have to replace this with A implies B and B implies A. This is the replacement to be made. Then eliminate implication. If we have a statement like A implies B, then it should be replaced with not A or B. We have X implies Y. We have to replace that with not X or Y. Then in CNF, negation appears only in literals. Therefore, we have to take that not or negation into the inward portion. For example, if not of not A, we have to take this not into this bracket so that we will get A. This is double negation elimination. Then if we have not of A and B, then this negation has to be taken into A, into and, then onto B. So the final answer will be not A and becomes or. So or and not B. This is by De Morgan's theorem. Similarly, if the statement is not A or B, then the result will be, or the result should be, not A and not B. Again, it's a De Morgan's rule. So such changes has to be made on the first order logic statement so that it will be in CNF format. Finally, using distributive law on the sentence, it should be of the form A1 or B1 and A2 or B2 and etc. etc. AN or BN. So CNF can also be described as AND of ORs. We have so many ANDs of, these are all OR statements. It can be considered as AND of ORs. Similarly, we can have disjunctive, this is conjunctive, we can have disjunctive normal form or DNF, which is a reverse process. There we will be getting A1 and B1 or A2 and B2. All these ORs will be replaced with ANDs and all these ANDs will be replaced with ORs. So in DNF it is OR of ANDs. Here it was AND of ORs. Here it will be OR of ANDs. Okay. So by an example, the things will be very clear. Let us see an example with this knowledge base. These are all some facts given and our goal is to state that this statement is true. It will rain. The statements or knowledge facts are: the humidity is high or the sky is cloudy. Then if the sky is cloudy, then it will rain. If the humidity is high, then it is hot. It is not hot. So in these things, never ever we have given with this statement, it will rain. It is all based on condition. So we have to ascertain this fact that it will rain from these statements given. So if the sky is cloudy, we can say that it will rain. So let us see how to develop this into a first order logic form, then into a CNF, and finally draw a graph to conclude that it will be raining. So let us, as part of the formation of first order logic, let us assume that humidity is high, represented with the letter P or literal P. Then sky is cloudy is represented as Q. Then the first statement can be rewritten as P or Q. Why? Because our first statement was the humidity is high, which is P, or the sky is cloudy, which is Q. So we can rewrite this as P or Q. Then we already have Q as sky is cloudy from this first step. Then let R be the statement it will rain. So R is assumed as it will rain. Then the second fact, what was the second fact? If the sky is cloudy, then it will rain. These are related, while these are not related. This statement is related on this statement. So if the sky is cloudy, then it will rain, which can be turned into Q implies R. If the sky is cloudy, it will rain. And on to the third fact, we can have this assumption: P is humidity is high from 1, then let S be it is hot. So again, they are related statements. If the humidity is high, then it is hot. So it can be written in FOL as P implies S. If the humidity is high, it is hot. Then the fourth one was it is not hot. We have already assumed S as it is hot. Then it is not hot will be the negation of this one. So the fourth statement will be not S. It is obtained from our assumption in 3. So this is the logical or first order logical form. So we were having 4 facts, and they have been converted into FOL as P or Q. Q implies R, P implies S, and not S. So we are generating the conjunct CNF form from this. So there is no change in the first statement because we are not having any implications. So P or Q remains as it is. Then the second statement in FOL was Q implies R, where we have to remove the implication. And while removing the implication, the rule was we have to negate the first literal and use the second literal with or, that is not Q or R. In the same way, we can rewrite P arrow S in the CNF format as not P or S. So these are similar cases. Then there is no changes in the fourth statement because it has only a literal in it, no implication. So it can be kept as it is. So it is not S. Then we have to negate our goal. It will rain was our goal. Then If we negate that, it becomes it will not rain. Okay. So we are contradicting our goal or assuming that our goal is wrong. Our goal to be attained is it will rain. So while negating that, we can term it as it will not rain, and we have already defined it will rain as R, so its negation is not R. So we have reached up to this point, not R. Now we have to construct a graph which is known as the resolution graph. So this was our first statement in CNF. This was our second statement, and while combining these two conjuncts, we have to remove the complementary literals. Here the complementary literals are Q and not Q. They will get cancelled and we will be available with P or R. So we have got a new fact here, P or R. Then it is being conjuncted with our third FOS fact, which is not P or S. Here again P and not P are complements. They can be cancelled and we get another fact as R or S. Similarly, we have not S in our statement set, and this S and not S can be cancelled because they are complements, and we finally reach at R. Then this was our assumption, which is the negation of R, and these two gets cancelled and we are finally available with a empty clause. When we reach an empty clause, we can conclude that our assumption was wrong. When the empty clause is empty, we can assume that our assumption is wrong, and our assumption was it will not rain, so we can conclude that it will rain is absolutely correct. This is the method of resolution. So after applying proof by refutation, that is by contradiction, which means that we will be assuming that the goal is wrong, and we will be proceeding and finally reach at a null clause. Then we have to revert our assumption and we thus reach to the goal. This is called as resolution.